Hello students, today we are going to talk about the part 2 of chapter 4, grade 6, sorting materials into groups. In this topic, we are going to discuss about the physical states of matter. Physical states of matter. So, coming to our topic, how many types of physical states of matter? There are, in your class, there are three types of states of matter. Three states of matter, in which first is solid, the second is liquid, and third is gas. These are the general states of matter, but two more states of matter you will study in your upcoming classes, that is the plasma state and Bose-Einstein condensate state. Okay, so in this class you will study about the solid, liquid and gases. Okay, so one by one I will discuss about what are the properties of solid, liquid and gases as with respect to these properties. Okay, firstly we will talk about, in solid, what is the position of molecules. This is the first property, that is position of molecules, how the molecules are represented and arranged in solids. Okay, in this property, the molecules, the position of the molecules in solid is fixed, totally fixed. What are the examples of solid? Some examples of solids are ice, common salts, the metals like iron, copper, in the like this, and etc. There are so many examples, but I gave you some examples how the molecules are arranged like this, in a proper way, and no any space between the molecules present. This is like this. You can see in the ice the arrangement, but you cannot see the normal eyes. From the normal eyes, what are the position of molecules, but in the microscope you will study about the position of molecules. In this property, the molecules of solid are totally arranged in a fixed order like this. There are no any space between the molecules. Okay, so this is the first property, position of molecules. This is the solid. Okay, and what about the liquids? What about the liquids? If we talk about the position of the molecules in liquid, that is not fixed but can move from one place to another place. I'll give you the example, like water, like oil. These are the examples of liquids. These are the examples of liquid. So when we talk about the position of the molecules, I take an example, that is, if you take water in your glass and roll over in your floor, that it can move from one place to another place. Okay, it can flow. So the position of the molecules in liquids are not fixed and it can move in its volume. Okay, so this is the position of the molecules in liquids. And what about the gases? Firstly, I am giving you some examples like oxygen, nitrogen, okay, nitrogen, carbon dioxide, water vapors, and what is the position of the molecules? There is no any fixed position of gases. The position of the molecules in gases are not fixed. If we take an example, if we take a balloon, then what is the position of molecules like this? The molecules are very far from each other. But if we talk about the solids, the arrangement of molecule are very close to each other, very much. There are no any spaces, but the space in molecules, in gases, is very far from each other. So this is some properties. First, this is the position of the molecules in solid, liquid, and gases. So again, what are the second property? The intermolecular forces. What are the intermolecular forces? Firstly, we should know about this topic, this point, that what is intermolecular forces? A special type of forces in substances by which the molecules of a particular substance held together. A special type of force in which the molecules of the substance held together and make a special type of shape, like solid. In ice, in iron, there is a fixed shape in which we can say that intermolecular forces of solid are very strongest. We cannot press the iron. Simply, we cannot press the iron because the intermolecular forces of solids are very strong. I gave you an example recently, but when we talk about the intermolecular forces of liquid, then it is lesser than the solid. Why it is lesser than the solid? But because it can flow. Liquids can flow, the water can flow, the oil can flow, but the intermolecular forces of liquid is greater than the gases. It has a capacity to hold together. The liquid wants, the molecule of liquid want together, to held together. Okay. So this is about the intermolecular forces of liquid. It is lesser than the solid but greater than the gases. And when we talk about the intermolecular forces of gases, then it is very much least at all states. It means the intermolecular forces of gases are very much poor. It means if we put some oxygen in our hand, it cannot held in our hand. It can move far from each other. We cannot hold the gases at one place. It can flow, it can move. Suppose a very much scent and fragrance spray in a particular corner of a room, it can spread throughout the room. Why? Because intermolecular forces of gases are very least at all states, regarding to the all states. So we can say that the intermolecular forces of gases is least at all states. Okay. And what about the intermolecular space? What is intermolecular space? The space between two molecules of a particular matter, a particular material, is called intermolecular space. So we can say that the intermolecular space of solid is very least, and there are no any intermolecular space in liquids. We can say that the intermolecular space in solid are least and most tightly packed. If we talk about an iron rod, if we talk about a chalk, then we can say that the intermolecular space of iron is very much least, because it is tightly packed and it has a perfect shape, and it is a rigid shape, a hard shape. Okay, so if we talk about the intermolecular space of liquid, we can say that it is more than in a solid, but less completely packed, because it flows from one place to another. So we can say that it is less compactly packed. It is less rather than the solid. But when we talk about the intermolecular space of gases, then it has a largest of all states and not completely tightly packed to each other. When we take an example of oxygen, so the molecules of oxygen not completely held together and it can spread throughout a particular space. So we can say that the intermolecular space of gases are largest of all states and not packed. So it has not it is the very next our topic, that is what about the volume. This is next property, that what about the volume. The volume of a solid is definite, it has a definite shape, it has a definite it has a definite volume, it has a definite volume. If we talk about a glass, it has a perfect volume, it has a definite volume, it cannot be changed. And if we talk about the volume of liquids, then it is also definite. If we talk about one glass of water and we poured the one glass of water in a balti in other container, then the volume of that particular water does not change. Okay, but we talk about the volume of gases, that it is not definite. That is not, it is not definite. Why? If we poured some oxygen, a little oxygen in a particular container, it can fully packed at that container and occupy the total space. And if we talk about the volume of the gases, that it is not definite in volume. So this is all about the volume. And recently I talked about the volume. What is volume? Volume is that the space present in a particular container, in a particular object. So this is all about the volume. And next is the shape. This is very simple. So what about the shape? The solid has a fixed shape, it cannot be changed until we rise the temperature. Okay, and what about the liquid? The shape of liquid is not fixed. Why? Because it flows. And the shape of the gases is also not fixed. If we take some gases in a particular container, it fully occupy the space, and if we take same gases in another container, it also occupy the whole shape. So this is all about this lecture. I hope all things are clear to you. If any question regarding to this topic, the solid, liquid and gases, you can ask. And one more thing, that in our nature there is only one substance, I think there is only one substance that is present in all states, that is water. Water can present in solid state, in liquid state, in gaseous state, all of the states. In solid state it can present in ice, in liquid state it can present in water, and what about the gases? It is present in water vapor state. So I hope all things are clear to you. Thank you so much, and I'll meet in our part 3. Thank you.